Greetings, everyone. Let's go look at, for quiz 5, I'm going to ask you to do Euler's, not Euler's original method, although this will be part of it, but I will want you to do it on the so-called semi-linear method. That was at the end of the lecture that we talked about this. So let me quickly review this. So a semi-linear differential equation, what is that? It's a differential equation of the form y prime plus pxy equals, now if I would write fx, I would get a linear, but if I write fx that depending on x and y, so a function both of x and y, and it could be very wild in terms of y as well, that is called semi-linear. Okay, semi-linear because there's the linear part and whatever that is. Semi means half, but here it means like almost, kind of, okay? Right, and what is then the method? Well, the method is then that we have if we take the homogeneous part, or the complement, sorry, not the homogeneous part, if we take the complementary equation, which for us will be this side, right? By definition, that's what we will call the complementary. We can solve that, separation of variables, and then we do the method of separation, variation of parameters, and then apply to that Euler's method. Let me give the example that I want to work out. I'm only going to do one because it's a kind of already quite some calculations. So, and it looks a bit ugly, but trust me, I made it so that it actually comes out not too bad. Plus 10 to the power, and here is where you might start freaking out. 4x minus 5 minus x squared. So that's all in the denominator, so in the exponent. And then we have also an x ln x squared here. So this is an extremely ugly term, but trust me, there's a reason I do this. It's an initial value problem. Now, notice that, well, first of all, it's actually not in the standard form because the x ln x, so I'm going to have to divide by it. And in particular, I cannot expect these things to be 0, so x cannot be 0 and x cannot be 1. So I'm going to start from 2. And I'm going to say the special value there is 3 ln 2. So this means what? At x0, y0, the very first point of my calculation, so if you would draw the, I'm not going to make this is too much to punch into a direction field, but you can if you want. If you put this in direction field, so we're going to have somewhere, we have this point here, this is the point x0, y0, and it's from there that we have these arrows that tell us where to go, okay? So that's our initial point here, is therefore the point 2, 3 times ln 2. And again, the reason for this ln 2 will make it, you'll see, it makes it actually nicer. Okay, and so when I tell you to use semi-linear method, I don't want you to do anything else, not the linear method, but I want you to do, not the original method, I want you to do the semi-linear method. You're not going to get credit if you just do the Euler method itself. It's semi-linear with steps of size. Now here in the textbook they take 0.1, 0.01, 0.25, something small. I'm actually going to take h equals 1. Again, that makes the calculations nicer. And the reason that it is kind of allowed is because of this term here, this forcing function, or whatever you call this, makes things kind of okay. For even h1 is for this type of function, it is a relatively small number, step. That is something I don't want to discuss here. Let's just say it's to make the calculations easier. And how many times I want you to do this for I equal 1, 2, and 3. So in other words, I want you to calculate x1, y1, x2, y2, and x3, y2. Okay, so how does it work? Well, step 1, we have to get to the variation of parameters. So we have the complementary homogeneous. So that was, as I said, in general, this is how this looks like. Yeah? This would be this equation. So what is this for us? Well, first of all, perhaps I should write therefore my equation again in the standard form. Divide everything by x ln x. So x ln x, x ln x, x ln x. And you see here now, this already, a couple of things cancel here. And that's the reason that there's such ugly terms at the side. So we get now y prime equals y over x ln x plus this ugly term 4x minus 5 minus x squared times ln x. There's only one ln x left. So this is going to be our differential equation. Let me copy it and I later can paste it. if I need it. No, that's not good. Why am I always... Okay. Hey, sorry guys, this is waste of time. I don't know, what is it doing now? No, I don't know what happened. Okay, sorry. I'm wasting time here just for nothing. Let me do it one more time here. Why do I... Jesus. Okay, get rid of this line, because this line always bothers me. I want to make sure that I get the whole thing. Okay, there we go. And now copy. Okay. So, what is the homogeneous one? Y prime equals y x ln x, right? I keep it this way because you're going to have to separate variables, so it's quicker if we do it that way. So separating the variables, we know that is what happens with linear homogeneous. So we get y prime of dy over y. Let's write it this way already. And then over here, we get dx over x ln x. Okay, and the derivatives, that is ln y. What happened here? You want to take integration by parts because there's an algebraic and logarithm, and so, no. ln x, it's on its own is a logarithm, but it's not in the numerator, it's in the denominator. So it's 1 over ln x, and that is not considered to be a logarithm. Okay? So, no, integration by parts doesn't work, ILate doesn't work. What we have to do, the only one thing that remains left in these kind of things is substitution. And so, but why? Because if I take the derivative of ln x, I know that this is 1 over x dx, and that's exactly what I have here, right? So this is exactly this part, and then the ln x is this one. So I can plug everything in, and this becomes just dw over w. So this is just ln w plus a constant. But don't forget, ln w itself is an ln x. Okay, we take the exponentiation. It's always the same here to get solve for y. Y is now e to the ln x times e to the d. Let me already do this, right? And then e to the d, we're going to write c. Now what is happening here? Of course, one of the e's and the ln's are going to cancel, right? These two are cancelled. So finally, I find y is c times ln x. Again, if you don't see this, do take your time and look at it yourself. Okay. Step 2 now is the variation of parameters. In this case, I don't need the general homogeneous solution, so I could have taken d equals 0, and so, because I only need one homogeneous, namely for c equals 1. I'm going to take that, ln x, and I multiply it with this parameter, u, and that is going to be my new y. Okay, the one that we're going to use. We're not going to do a particular solution. We won't be able to, well, we will reduce it to some particular solution, to finding a particular solution, but we'll see that we get stuck. We'll see right away. So, okay, when we have this, we're gonna have to take derivatives. So u prime, derivative of the first, copy the second, plus copy the first, take derivative of the second, which is 1 over x. Okay, and now I plug this into my equation. So I had this here. So this would be, that would be equal to, right, y, but be careful, y is u ln x. So u ln x divided by x ln x, plus, and then this term, that nothing happens with this term because there's no y in there. Okay, and we know that there are always some calculations. Well, first of all, these two cancel, and not all u's will cancel in general. In this case, yes, because there's no u in here, this part here, but normally this part would have u's in it as well, in the semi-linear part, right? But these two, you see, this ux and this ux cancel because they're on different sides of the aisle, let's say. Okay, so what we're left with is u prime ln x equals this thing. We see that the ln x is then cancelled. Let me write it up here. So u prime ln x is 10 to the 4x minus 5 minus x squared ln x. So the ln x is cancelled. And so we're left with u prime equals 10 to the power 4x minus 5 minus x squared. But this is an antiderivative problem. We just have to antiderive. The problem is that this cannot be antiderivative. The exponent is a quadratic, and there's absolutely no way to deal with this. So this is unsolvable as an integral, and so we have to use a numerical method. And so we're going to use what do we do now? So step 3 is we now use the actual Euler's method itself, the original method, on this differential equation. So very quickly, how does it work in general? So let's do here review of Euler's method. So we have y prime equals a function in terms of x and y, and then we gonna take xi's is gonna be we're gonna recursively we start from x0 y0, and then we recursively define new points, right? So what we're doing is basically what you saw on this direction field grapher is following the arrows. Okay, and so we do the formula is, I write down the formula. Oh no, sorry. This is y, right? So wait, give me a sec here. So in the x direction we just take equal steps, right? We go with step by step. So this is in general this is h here. It's in the y direction that we have this formula that is the recursive formula. A formula that uses previous values, for those that don't know what that means exactly, recursive, but I'm sure many of you have heard of that. So that's the formula. Okay. Good. And so we keep calculating this. From 0 we can calculate x1 and y1, and then so on and so on. So we do this on this particular equation here. So what happened here? So we have u prime is equal to this px, and this is the px here. Well, let me write it this way. Let me not copy it. Let me write it this way. So this is going to be our px. And I find it easiest to make a table here. So I'll make the table and the side a little bit. So what am I going to do? So I'm going to take I have to do 3 steps, right? I mean, the 0th step, of course, is just the initial step, so I'm going to write it here. So I'm going to calculate xi. And I have to do it on this differential equation, so not y's, but u's now. ui. And then what is my p? My p is actually this expression here, 10 to the 4 x minus 5 minus x squared. And I'm actually what I'm gonna plug in all the time is the xi's and the ui's. There's no u's, so only the xi's. So actually, if I want, this is what I'm gonna plug in. Now, what I really want is the yi's. Don't forget that. And how are they linked? Well, we have y equals u ln x, right? So this yi is just xi ln, sorry. It's a bit more space here. So this is yi is just ui times ln of xi. But that is just plugging the number that I find, these numbers here, these numbers will calculate, using these two I will calculate that. And so using this number I will calculate that. Okay, so that's how we built up the table. So the question is really, how do we find these numbers? Okay, everything else is kind of on the table, but we have to find these numbers. And how we do that, that is this recursive formula. So let's write down what it means for I equals 1. So, okay, we know that we start at 2. Okay, and we know that at 2, okay, the first question is, what is the value of u at 2? We know that the value of y at 2 is 3 ln 2, right? It goes back. 3 ln 2, right? So we know that this is 3 ln 2. So y0, which is u0 times ln of x0. So we know that y0 is 3 ln 2. u0 we don't know yet, and x0 was 2, is ln 2. So we see that u0 is actually 3. Okay? You see that? So that's again why there was an ln 2 here, so that the u's actually become very easy number here. You understand what I'm saying here? So at the original point, the value was, the y value was 3 ln 2, but y is u times ln x. And so this means that u therefore must be 3. Okay, so the one thing that we need to calculate, so let's write down the formula. For u1 now is u0 plus h times p of x0 u0. And write down the general case, but there are much less to do here. u0 we know that is 2 plus h is 1. So we don't have to write that. And this p only depends on x0. So we have to calculate this. So the calculation of px0 here, what is that? Well, we have to plug in 10 to the 4 times, x0 is 2, right? 2 minus 5 minus 2 squared, 4. So 8 minus 5 minus 4, that is negative 1. So 10 to the negative 1, that is 1/10 or 0.1. So 1/10 and 0.1. You can use either one, but you'll see it's actually, in some sense, U0 is 2, no, U0 is 3. Very careful here because there's so many different numbers running around. U0, look in my table, was 3. So 3 plus this thing we now calculate to be 1/10. Okay? So where are we? We see that this is 3.1. That's why it's easier to write it in decimals here. Otherwise, I have to write 31/10, but it's easier to write 3.1 here. What is x2? Well, x2 of course is 3, right? I hope that's because I'm going by steps 1. Steps 1, h is 1. Okay, so that's that. So what we'll need next? We will not need to calculate this number, right? The next thing that we calculate in this table is this number. So let's do this already. So I'm going to do it here. P of, now what is that number? I have to plug in x1, which is 3, right? I plug in this x value now and plug it in here. So P3, so what is that? That is 10 to the 4 times 3 minus 5 minus 9. That is 12 minus 14, that is 10 to the negative 2. Oh, that's actually nice. That is 1 over 10 to the square, which is 0.01. Okay. Let me fill in the y's at the end, because that's not important. Right? Okay, so what are we going to do? Well, the formula says U2 is U1 plus h times P x1, y U1, but there's no U1, so let me not write it, and there's no h, so let me not write it either. H is 1. Okay, and so U1, we have that's 3.1. And we just calculated px1 is 0.01, so just where this comes from, right? This is the 3.1, and this is the 0.01. Okay, we put these two together, and so we see that this is equal to 3.11. So 3.11. Now we know what x2 is. The next is just one further, right? H is 1. Okay. So what is next to calculate is what goes in here. Okay, that is the calculation. So sorry, perhaps let me keep putting arrows to say where everything goes. This one was calculating this value here, right? So now I'm going to calculate P4, and that will go into this slot here. Okay, so P4, because my x2 is now 4, is 10 to the 4 times 4 minus 5 minus 4 squared, 16. Oh, the 16 cancels. 10 to the negative 5. That is, so 10 to the negative 5, which is 0.1, 2, 3, 4, 5, right? Okay. Now, the recursive formula says U3 is U2 plus H, but H is 1, P times X2. There's no U2, so I don't have to plug it in. We just calculate that number, right? This is the blue number that I calculated here. So that I'm going to plug this in here, and the U2 I have also, right? This is the U2 now. Okay. So what we get is 3.11 plus 0.00001. So this is 3.11001. I hope I put the numbers correct here. Okay. So this is 5, and this is 3.11001. Now I only ask you to go up to here, so we don't even need to know this. So this one is not necessary, because this we will only use for the next value. We don't need this. Now technically we only calculated the use, so we should be writing down what is happening here. Well, this would be, remember, this is the formula now. You take this ui and multiply with the ln of this number. So this would be 3. Oh, what was that? This would be 3.1 ln 3. The next one would be 3.11 ln of 4, and this one is 3.11001 ln of 5. Okay. And so you see that this, although we did, okay, this is the end of the story. But I just want to comment that h equals 1 is often not small enough a step. And why can we tell that the step is small or not? If the values that we find, the y values we find, are relatively close to each other. Okay, now, granted, it's not really true because, okay, you say, oh, 3.1, 3.11, 3.11, they're close to each other, but we're multiplying it with an ln, so it makes it slightly bigger. So it's not entirely right, but it's not bad at all. Okay, so it is acceptable here. Okay, that's the quiz, and I hope that you'll be able to do the quiz in a similar manner. And again, you might get a bit ugly looking function, but the whole point is that it actually the calculations are easier than the table, the calculation of the table, the Euler's method itself. This table could be very ugly, and I want you to do the calculations like this, right? Show every calculation, because it's not just, if you do the Euler's method, you just have to put this into an Excel sheet or another or run it through a program. Here you can do step by step, show every step what you're doing. And I'm only asking 3 steps, which is not, you see, very little computation here. Okay, so make sure you do all this on the quiz. All right.